I'm going to look at a goodness of fit test or a test of proportions, and I'm going to be testing the region data, that is the region that each house has come from in the real estate data set. If I go to Stat Tables, we want the third option here, the chi-square goodness of fit test for one variable. In this case I don't have the counts as such, I've got all of the data in one column and I need Minitab to go through and count that up for me, so I'm just going to put region in the categorical data. First of all, let's try testing it for equal proportions. If I go to graphs, you'll see that it'll do a bar chart of the observed and expected values, and it will do a bar chart of the contribution to the chi-square value. Now it can do these from largest to smallest, but in this case there's only 4 regions and they're numbered 1 to 4, so I think I might like to see them in order, so I'll unchat. Okay. So because we were testing equal proportions, we can see that the expected value is the same for each of the categories here. 69.5 is the expected value, so that will be a quarter of the 278 observations. So regions 1 and 2 are fairly close. Region 3 was a lot less than expected, and region 4 was a lot more than expected. So we might expect that these two will contribute the most to the chi-square test statistic. Here we've got the contribution by the category, regions 1, 2, 3 and 4, and 4 is definitely having the biggest impact. If I close these off, close that off, and here we can look at the actual test. These are the observed counts, the expected counts, and the proportion that this was out of the total, 0.25 or a quarter, and the contribution to the test statistic. So this is all the information that was on the graphs. N 278 observation, 3 degrees of freedom, because we had 4 categories, 4 minus 1. Here's our chi-square test statistic, and here's our p-value. Now remember that the null hypothesis is always that our observed values have come from these proportions, and here the p-value is very small, so the chance of observing this particular data if these proportions are correct is very, very small. So this would lead us to conclude that these proportions are not correct. Now the second way of testing this is if we go back to tables chi-square one variable. Now instead of equal proportions, we had in the lecture notes some historical counts of new homes being built, and they were 25%, 20%, and 35%. So now we can test to see if the region data actually matches this historical data of new homes being built. Okay. This time we see that there's a closer match between regions 3 and 4, and actually region 1 is contributing the biggest value of the test statistic now. Close these off. Let's look at the actual test. So here's our observed values, here's the historical counts, and Minitab has calculated out the proportion, and here's the expected values. So the contribution to the chi-square test statistic, degrees of freedom is still 3. Our chi-square value is much smaller now, so we're getting a lot closer match to the expected frequencies, and we've got a p-value of 0.055. So there's a 5.5% chance of observing this data if these proportions were correct. So I would say that that's not enough evidence to reject the hypothesis that the homes are being sold in the same proportions that the new homes are being built.